Imagine a time thousands of years ago, no satellites, no telescopes, no supercomputers. Yet somehow, ancient thinkers measured the size of the Earth, the Moon, and even the distance between them. Today, with all our technology, some still debate the shape of the Earth. How did they achieve so much so long ago? Our story begins in ancient Greece around 240 BCE. Eratosthenes, a Greek mathematician and librarian of Alexandria, made an astonishing discovery using nothing but shadows and geometry. He noticed that on the summer solstice, the sun cast no shadow at noon in the city of Syene, modern-day Aswan, but in Alexandria, 800 kilometers north, there was a noticeable shadow. By measuring the angle of the shadow 7.2 degrees and knowing the distance between the two cities, he calculated the Earth's circumference. The math is surprisingly simple. If 7.2 degrees is 1/50th of a circle, then the full circumference must be 50 times the distance between Syene and Alexandria. Eratosthenes measured the Earth's circumference to be about 40,000 kilometers, and he wasn't far off. The modern value, 40,075 kilometers. Imagine the awe and disbelief when people realized how massive their world truly was. It must have been humbling and mind-blowing. But the Earth wasn't the only celestial body they measured. Around the same era, Aristarchus of Samos turned his attention to the moon. During a lunar eclipse, he observed the Earth's shadow on the moon and compared its size to the moon itself. He deduced that the moon was about 1/3.7 the size of Earth. Next, he tackled the moon's distance. By observing the moon's phases and using trigonometry, Aristarchus estimated the moon was about 30 Earth diameters away again, remarkably close to the modern value of 27.3 Earth diameters. With this distance and the moon's apparent size in the sky, he calculated its actual diameter. It was smaller than Earth, but still enormous, 3,500 kilometers across. Think about the tools they used: sticks, shadows, and simple geometry. No telescopes, no calculators. Yet they uncovered the immense scale of our world and its celestial neighbors. And they did it thousands of years ago with logic as their guide. Today, with all our advancements, many still can't grasp these calculations. Some even question whether the Earth is round, despite overwhelming evidence. So what did they feel when they learned these truths? Imagine being told that the Earth you walk on is 40,000 kilometers around. To them, the world suddenly became unimaginably vast. It must have sparked both wonder and humility, knowing they lived on a giant sphere floating in an even greater unknown. And when they looked at the moon, they no longer saw a mysterious glowing disk. They saw a massive sphere orbiting Earth at an immense distance, part of a celestial clockwork that begged to be understood. The sun was a source of awe and mystery for ancient civilizations, and while they managed remarkable measurements of the moon and Earth, understanding the sun was a more elusive challenge. Early civilizations saw the sun as a godlike entity, often central to their mythologies. For example, the Egyptians worshipped Ra, the sun god. The Greeks associated the sun with Helios, riding his chariot across the sky. To them, the sun's power to give light, warmth, and life was undeniable. But its true nature and size were unknown for centuries. By observing the sun and moon, early thinkers noticed they appeared the same size in the sky. This observation led to profound questions. If the moon is much smaller than Earth and is about 384,000 kilometers away, how far must the sun be to appear the same size? The first major breakthrough came with Aristarchus of Samos, 310 to 230 BCE. Aristarchus compared the apparent size of the moon and the sun. Using geometry during a lunar eclipse, he deduced that the sun had to be much farther away and vastly larger than the moon. His calculations suggested that the sun was about 20 times farther than the moon, and several times larger than Earth. While his estimates were incorrect, the sun is approximately 400 times farther, the key insight was groundbreaking. This realization that the sun was enormous and far away was humbling. It positioned Earth as a much smaller player in the cosmic theater. Measuring the moon's size and distance was relatively straightforward because the moon's orbit is directly observable from Earth. Lunar eclipses provided a clear way to compare Earth's shadow to the moon's size. The sun, however, posed several challenges. 1. Its brightness. Direct observation was difficult and dangerous without modern tools. 2. No eclipses. Solar eclipses were rare and hard to study safely. 3. Lack of accurate instruments. Early methods couldn't precisely measure the sun's distance or size. For centuries, the sun remained a mystery, even as the moon and Earth were understood better. Ancient astronomers must have been puzzled and perhaps frustrated that they could measure the moon's size and distance, but not the sun's. They knew the sun was farther and larger. But without accurate instruments, they couldn't determine its exact size. Their limited understanding of light and optics also hindered their ability to grasp the full picture. It wasn't until Copernicus, 1473 to 1543, Kepler, and Galileo that the sun's true scale became clearer. Kepler's laws of planetary motion showed the heliocentric model with the sun at the center was correct. Later, the transit of Venus, a rare event where Venus crosses the sun's face, allowed astronomers in the 18th century to calculate the sun's distance accurately. They found it was about 150 million kilometers away, what we now call an astronomical unit. With this distance known, the sun's size could finally be calculated, about 1.4 million kilometers in diameter, dwarfing Earth and the Moon. When humanity realized the sun was not a small ball in the sky but a massive distant star, it was transformative. This knowledge challenged religious views, inspired new scientific theories, and humbled humanity's sense of importance in the universe. In ancient times, the sun's immensity was unimaginable, but as the tools of science improved, our understanding of its true scale and our place in the cosmos grew, culminating in the realization that our sun is just one of billions of stars in an infinite universe. If you enjoyed this journey into ancient genius, don't forget to like, subscribe, and share.